This proof here, I'm going to look at the proof statement and recognize that's kind of different than anything we've done so far. Everything we've done has been, you are done with the proof once you get triangles congruent, or you are done with the proofs once you make one statement after that about congruency of any angles or congruency of segments. This is now classifying a shape as a particular kind of operator. And we're going to say BD is a bisector of angle ABC. Okay, so we're going to define BD. We're going to categorize it as something. Okay, so it's going to be a little bit more, sort of one step more involved than what we've done yet. Okay, so far. But we look at our picture, so we don't know what, maybe at the onset, don't know how to prove what they're trying to get to. We take a moment, look at a picture, and say, oh, well, there's triangles there, so what should I try to do? Okay, try to show the triangle is congruent. Good. So, I'm going to, and now there's really 4 triangles there, right? Yes. Hopefully we all recognize that the big triangle ABC is not going to be congruent to any of the smaller ones, right? No. Okay. So, we're looking at these 3 smaller triangles, and I'm not sure which ones to choose. Okay. So, I'm going to put marks on these. Okay, this is another reason why we need to put markings in our picture, because now, by putting those markings in the picture, if I look at, this purple triangle and this one down here, you have one common congruency, right? AD is in both those. Okay, but AB, which is in the purple one, does not have a congruency into the blue triangle, right? And then DC is a congruency in the blue one, but that doesn't show up in the purple, right? So you only have one congruent statement between those 2 triangles. And for the same reason, you only have one congruency for those 2 triangles, okay? The one on the right and the one on the bottom. So what happens here is that those 2 triangles were actually kind of bad ones to look at. This triangle right here and this triangle here are the ones that we want to try to prove congruent. Okay? Because when we look at them, and I erase that mark right there, you have now 2 segments in the purple one congruent to 2 segments in the blue one, right? Yeah. And that's more information than what you had when you compared either of those to the bottom triangle. What is the additional piece of information that we know? Careful. We want to try to prove triangles congruent. So that's the first task. So right now I've got 2 things congruent to 2 things. I need a third thing, right? Yes. What do you know for certain by looking at your picture is in both triangles? Okay, they share BD. So I'm going to write that BD is congruent to BD. That's the reflexive property. Okay. Now, what does that tell you about the purple triangle compared to the blue triangle? You've got 3 congruencies now, right? And there are the 3 sides. So what does it tell you you say about those 2 triangles? They are themselves congruent. So let's say triangle, I'm just going to call it ABD, congruent to triangle CBD. What's my reason? SSS. Okay. Whenever we want to make triangles congruent, it's always going to be, right now, it's always 3 letters. Okay. Now, just like any other proof we've done, once we've shown the triangle is congruent, we want to look at the line that we just created. We want to look at this statement here and match it up to the proof statement. And our hopes are is that they're identical. And then if they're identical, we're done, right? But here they're not. Okay? So we got to be a little bit thoughtful. If they're not, the ones we've seen up until today have been one step of CP/CTC, and you're done, right? This one is going to actually take 2 steps, okay? But every time you make an SSS statement or SAS statement using one of our triangle congruency postulates or theorems, the next step will always be CPCTC. All right? So we want to eventually get to the fact that BD bisects ABC. Okay? Well, BD is going to bisect ABC. What does it, and it's bisecting an angle, right? What does an angle bisector always provide you?
Right angles.
Sometimes, if you bisect a 180-degree angle.
Two equal things on each side.
Okay, so an angle bisector will provide you two equal angles, right?
Yeah.
If BD, if that segment right there is going to be an angle bisector of that angle right there, okay? So the red segment is going to be an angle bisector of the green angle. Which two angles would have to be congruent in order for BD to be a bisector? Which angles, if I'm looking at the green angle, which angles make it up that would have to be congruent to make BD an angle bisector? Right, this angle right here, that red angle, and that blue angle, those two things would have to be equal if BD is going to be classified as an angle bisector, right? So once we say the triangles are congruent, are those two angles congruent? Is ABD, A to B to D, in that order? Is it the same order as CBD? If we trace those out, does that give you the same angle?
Yeah.
Okay, so we can say that angle ABD is congruent to angle CBD by CPCTC. Okay? Now, what it might be problematic for some people in this step right here is developing that, because it's really nice to be able to say, maybe like angle A congruent to angle C, or angle D is congruent to angle D, or angle B is congruent to angle B. Those things would be really nice in other proofs. The way we've used other proofs, if they're identifying the angle with one letter, it's really easy to use CPCTC. But if I have to identify the angle with three letters, which we have to do here, because if I just say angle B, there's three angles that exist at that vertex. So if I want to use three letters, you just take those three letters out of your name here, okay? And whatever pattern you use to name them. So I used A, B, and D, right? Those were the three letters I wanted to use. So they became first letter, second letter, last letter, okay? So over here I gotta use first letter, second letter, last letter in that order, and that traces out an angle. Let's say for some reason, maybe I wanted to talk about those two angles. Those are congruent, right? By CPCTC. But I don't want to call it angle A, I don't want to call it angle C, I want to call it BAD. Well, BAD would be middle, so middle letter to first letter to last letter, right? So BAD should match up to B, C, and then to the last letter D. Does that kind of make sense to everybody? So if you have to use three letters, follow the same pattern that you identified the first angle with in your triangle to come up with your second angle. Right? So that's how we get ABD congruent to CBD, CPCTC. So now, if those two angles are congruent, and BD is that thing in the middle, that ray in the middle, that segment in the middle, that is actually cutting that angle into two equal parts, what does that make BD? A bisector. Okay? So we say BD bisects angle ABC. Or you can write that BD is an angle bisector. And I like saying BD is an angle bisector because I just classified it as something, right? I've just named it as something, okay? If I were to say Carter is a sophomore, how do I know that? How do I know you're a sophomore, Carter? Okay, because you're in 10th grade, but how do I know that 10th grade is a sophomore? We have, don't you have so many credits to become a sophomore?
Yeah.
So somewhere we have defined what a sophomore means, right? In a definition somewhere we say a sophomore is a person that's in their 10th year of education and they have X amount of credits accrued, okay? So whenever you classify something, okay, whenever you make a distinction about an object and name it, okay, you're using a definition, right? So I said BD is a bisector. how do I know that? Because I know what it means to become a bisector, right? I know what the definition of a bisector is, and by knowing that definition, I can classify things as being bisectors. So this is going to be a definition of an angle bisector. Okay, definition of an angle bisector.
You know how you like, when you like cross out facing on something, how do you do that?
Use the snipping tool. All right, so we want to take the proof that we just did, okay, and I want to transform it into a paragraph, okay? So take what we just did and put it in paragraph form. When you guys are in English class, what is one of, you're on paper, what's one of the first things you do when you're on paper?
Put a title on it.
Okay,
Put my
maybe.
name on it.
A lot of times maybe the title is the last thing you do.
Put my name on it.
Put your name on. Somebody else will ask us. Okay, yeah, you can put your name on it. But in the event of
Wait, oh, you gotta save it.
writing a paper, what is the first thing you do? Like you don't just sit down and
Oh,
write.
you get the paper out and the pencil, if you're writing.
Right, but
You turn the lights on so you can see.
like in that class, so Mrs. Ellington's class, right? That's what class you guys are in?
I have posters back.
Mr. Stone, if we're going to write a paper in either one of those classes, they don't just say, hey, write a paper over mice and men
Oh, you
or
gotta pick a
Frankenstein or whatever. You pick a topic, right?
Yeah.
Or they give you a topic, they give you a prompt to write on. But the days leading up to when you got to turn it in, what do you work on individually in those classes prior to turning it in?
The paper,
Right, but
finding facts about the
say again? Well, you might read the book, yeah.
facts.
Don't you think about how I'm going to organize my paper? No, you just start writing. You start writing your final draft right away.
I might do
You might do a rough draft, okay? Okay, so you go do a rough draft. What would you do before a rough draft? You do this in all those classes. And I know because I had those people teachers.
outline.
You do an outline, okay? And an outline is something that's going to organize your thoughts, right? It's going to tell you these are the things that I want to put in my paper, okay? Or these are the things I'm thinking about putting in my paper. Then you start writing your rough draft, and you in your rough draft you should target those things that you have in your outline, right? Your outlining rough draft should be comparable to one. Then your rough draft is going to get finalized into a final draft, right? And you start maybe in your final draft. Your rough draft should not be exactly the same as your final draft, right? Maybe you've eliminated paragraphs. Maybe you took out sentences. Maybe you've added paragraphs, added sentences, whatever. Okay? They're still similar papers, but your final draft is what you want to submit at the end, right? When we do two-column proofs, our two-column proofs are outlines or rough drafts. Okay? When you want to submit a proof, okay, a professional-looking proof, you take your information and you put it into paragraph. You put it into prose writing. Okay? So I want to show you how to do this. It's really easy if you have the template of your two-column proof next to you. Okay? So first thing I want to do, I want to go through this and write this out with you guys. The way you write it might be a little bit different because the way you write, your structure, your prose writing might be different than your neighbor's, right? But the process is the same. Okay? I'm going to write something in the effect of, let's say, it is provided that AB is congruent to CB, AD is congruent to CD. Okay? So I want to be kind of grammatically correct here, so I'll write and instead of a comma there. Okay? All right, so that when I say it is provided, what's provided another word for?
Given.
Given. Okay? If you wanted to use the word given, that's fine. It is given that AB is congruent to CD and AD is congruent to CD. Now, I should be using the congruent symbols in the segment lines on top, but I don't have that ability on my keyboard.
Wait, so we should?
Yeah, you should write, when you're writing this by hand, you should put the symbol above AB and the congruent symbol and all that kind of stuff. Okay? So now I'm going to start basically, that was statement number one and reason number one, right? I'm going to go through my proof and I'm going to basically write statement number two and reason number two. And I'm going to write statement number three and reason number three. But I'm going to write it so it flows, okay? So that I have like transitions using words like then and therefore and so that or such that, stuff like that. Does that make sense? And the ones that you choose might be different than the ones your neighbors choose. The transitions that you use might be different, okay? So I'm going to write Something like maybe it is also seen that BD is equal to BD due to the reflexive property of congruence. Okay? Period or comma, however you want to structure it. And then I'm going to write, therefore, by side, 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 triangle ABD is congruent. And you can use the symbols. I'm just going to write it out. To triangle CBD. Okay? As you're writing it in your style, you might be a person that said, therefore, triangle ABD is near triangle CBD by side, side, side. Okay? If you write it that way, or you write the way I wrote it, you're saying the same thing, right? You're writing a statement, and you're giving a reason why you wrote that statement. Okay? Let me change the font on this real quick. Okay. Thus, angle ABD is congruent to angle CBD by CPCTC. Allowing to develop the conclusion that BD is an angle bisector of angle ABC because of the definition of angle bisectors. And that would be a sufficient way of writing that as a paragraph proof. Okay. Now I say, comma, allowing you to develop the conclusion that BD is an angle bisector of ABC because of the definition of angle bisector. You could have also said, therefore, it is shown that BD is an angle bisector by the use of the definition of angle bisectors, or you could say, therefore, it is proven that ABC is an angle, or sorry, BD is an angle bisector. You can phrase things a little bit differently. Does that make sense? Yes. Okay. In Math Excel, you saw yesterday, maybe they have some drop-down windows for you, right? Okay, so they already have like 5 or 6 predefined statements that you could possibly make, one of them being the best, and then you're choosing that best one. On an intercourse exam, they might ask you, write a paragraph proof. Okay? First thing you need to do is set up a 2-column proof. And then once you have that 2-column proof, you go through line by line, basically writing line by line down, and using transition words like there, then, thus, then, therefore, in addition to, stuff like that. Does that kind of make sense? Is that a task? Is that hard?
Yes.
It might take some writing, but is it mentally hard, difficult?
No.
No. Okay. The hopes that we see is that first, and you can do it this way. You can go sentence by sentence. First sentence is statement and reason number 1, right? Second sentence, statement and reason number 2, right? Third sentence, statement, reason number 3, right?
Yeah.
Fourth sentence, okay, now I got comma in there, but fourth sentence right there before that comma, statement number 4, reason number 4, and then the last portion, statement number 5, reason number 5. All right? So when they ask for a paragraph proof, that's what you need to do. Write your rough draft, write your template over here, and then transfer it over to a paragraph. Okay, I'm going to ask you to do that at some point on a test or a quiz. All right, let's do. We got time. Let's do one more proof. Let's go with. Give me a minute to write that one down. Okay, so we write our given down. When we look at our given, there's 3 congruencies there, right?
Okay.
All right. So what I want you to make sure you're paying attention to is what those congruencies say. Not that you have three of them, but what all three of them are saying. Because in the last couple classes when we did this one, people were saying, well, you got three congruencies, so those triangles have to be congruent or left. Okay? Well, if I look at what they're talking about, HK congruent to LG, they're talking just about those green parts, right?
Yeah.
Okay. Then they give me those two congruent, and then they give me those blue ones congruent, right? Do I have all three sides of both triangles being congruent?
No.
No, we only have parts of that third side, right? We only have a part of HG being congruent to a part of KL. We need to be able to show that HG is congruent to KL. Okay? And if I can show that, HG and KL are congruent, then we have side, 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 correct? And then we show the triangles are congruent. So I want to show you it's a common practice with a lot of proofs that we go through using 2 or 3 steps here to get that fact that HG is congruent to KL. And doing this is going to use some segment addition concepts. Okay, think about this. If you start with those two things, or that thing there and that distance there being congruent, okay, and then you add the green one to both those blue segments, right? So think about the blue one on the left plus the green one will give you that segment right there, correct? Does it make sense logically that that has to be identical to that one right there?
Yeah.
Because the blues were the same, and then you added the same amount for both of them, right? So the conclusion is that the two sums that you have at the end should be equal as well, okay? We just have to be, so kind of logically or with our thought, it makes sense that those have to be the same. But we have to write that out in a proof. We have to show why that's the case. So here's what you want to do. If I'm just going to look at H to G, I want to focus just on that segment first. Okay? What two smaller segments make up H to G?
HK.
Okay, HK
KG.
and KG. And that is going to equal, if I add those together, that's going to equal HG, right? Okay. What allows me to add two segments together that are sharing a point, a shared K, to get the entire larger segment? You remember from that?
From midpoint.
No?
Never mind.
Sometimes midpoints are that middle point. If I stand right there and walk to K, stop, and then walk to G, what allows me to say that I've walked H to G?
It's something about distance, isn't
It is something about distance. Distance isn't the word that's in there. What are we doing here? What are these things? What is HK?
Segment addition.
Segment and segment addition. You take the segments, you add them together to get a larger segment, right? So that is segment addition. You guys remember that postulate? Okay, so the segment addition postulate. Okay. Now, H to G was one of the segments I was interested in. But isn't K to L another one of those segments that I'm interested in? So what are the parts that make up K to L?
L and G.
LG and
GK.
okay.
Okay.
Yeah.
Is those things right there up on your website or not?
This stuff here?
Like, not the yellow stuff, but like those two proofs in there.
No, those aren't. This is actually cut out from one of your homework questions that you're going to do tonight.
Did you write on there, Sharpie? Because that's been up there for a while.
No, I've never erased
I
it.
keep thinking that you're just trying to cover it up.
All right, so both those statements in number 2 came from segment addition, right? I have to create another statement that is independent of that. Okay, so statement number 3 is not impacted by statement number 2. Okay, but let's go to HK. I'm going to write HK down. I'm going to write LG down. What do you know about those two things?
They're the same.
They're the same. That was stated right there, right? So I'm going to write HK is equal to LG or GL. Okay. Now I should be using. We're kind of using. We're segments here, and I'm using notation that maybe could be better if we were using distances. It's kind of a notation type thing. Author to author might say we want to change all these to distances first using definition of congruency, and then do the work, do the algebra, and then change back over to segments later. Just to get through the proof and get the idea, the concept, I'm going to kind of skip over that. So ultimately, that should probably be a congruency symbol. If I've got that as a segment and that as a segment, or there should be a distance out the segment above, so that we can deal with equality. But I'm kind of glazing over that, so it's not a really big deal right now. If I look at HK and GL, would you agree that if I add that red segment to HK, and then add that red segment to GL, I would still end up with a statement that is equal Z? Okay, so I'm going to put plus KG there, and then put plus KG there, right? Does that make sense, everybody? So start with the green stuff, they were equal, added the same thing to both sides. Okay? Well, in an equation, when you start with two things that are equal, and then you add the same thing to both sides, you remember what property that's called?
Oh.
Add something to both sides?
Addition property.
Addition property of what?
Equality.
Yes. Addition property equality. Okay? Now, what I said is that statement 2 and statement 3 are independent of one another. So they could have been flip-flopped. You could have done the addition property equality first, and then the statement addition property. Okay, or possibly. But now, the reason those two things together are pretty useful is look at this. Do you have somewhere in your proof where you have already talked or identified HK plus KG as something? Look in the lines above it. Is there somewhere up there that we have referred to as HK plus KG?
Yes.
What?
The segment is something. Wait.
Okay, you said HK plus KG is right here, right?
Yeah.
So what can I replace HK plus KG with?
HG.
HG. So I'm going to replace it in line number 4. I'm going to replace this with what it's equal to, HG. Okay? Do we have somewhere in my proof where I've identified GL plus KG as something else?
Yes.
What have I identified that as?
KL.
KL. Okay? So I'm going to just replace this blue box with HG, this black box with KL. Okay, now that replacing is just substitution, right?
Yeah.
Okay, so substitution. Now I go to my picture, HG, what was HG? Well, HG now is that entire red segment. And we are shown that it is congruent to KL, but KL now is that entire green segment, right? So now have we shown that the third segments of those triangles are in fact congruent to one another? Okay? So if these segments are congruent to one another, I'm going to say in step 5 that triangle FGH is congruent to triangle JKL by side, side, side. We've got 3 sides in the top triangle, we've got 3 sides in the bottom triangle. Okay? As you go through some of these problems throughout the rest of the course, some of these proofs.
Is that it then?
Yep, we're done.
Oh, let's go.
That stuff that I just circled, in itself can be condensed to a theorem that textbooks don't talk about a lot. But we use that idea, that concept very often. That's kind of the idea of theorems, right? Is that you see something happening quite a bit, and from proof to proof to proof, and it's always a similar idea. So we give it a name of theorem, okay? And we can condense these 3 steps into 1 step. And that 1 step, I'm going to call this name, we'll do this again at some point. We'll call this the common segment theorem. And that would allow us to do this proof in 3 steps. Does that make sense? Okay? The common segment theorem is this idea right here. When you start with that being congruent to that, but you see if they have a common KG in them, they have a common segment being added to both of them, then the entire segments are equal. Does that make sense? Okay? We'll come back. We'll actually maybe probably not tomorrow, but maybe Monday or Tuesday next week, we will work with just the common segment theorem and prove that statement all by itself. So then it might make it a little bit easier for you to progress through other proofs. But I want to talk about that because you will see one of those in your homework tonight. I think it's like question 21 or 22. Towards the end of the assignment, they're asking you to do some segment addition stuff to show triangle parts congruent. Okay. Like I said, there's Simon WebSign, not WebSign, Matt Cassell.